Circular economy, definition, processes, and impact. If we take a look to the environment, we can see how nature follows a closed circle, where everything is useful, nothing is left, and the material flows naturally. When an animal dies, its body became food for other animals, and the remains become part of the soil substrate which it will be useful for other things. However, we as humans did not adapt ourselves to that processes. In fact, we have created the opposite, a linear approach, where we focus on create, produce, and discard. For example, if we have a cool and fancy mobile phone, but it breaks, instead of fixing the old one, we just throw it away and buy a new one. Each time we make this, we are exploiting a finite offer of natural resources, and in many cases, we are generating toxic waste. But let's think broader. Imagine that the goods we have today becomes the resources of tomorrow. Well, that is what circular economy focuses on. Instead of throwing away what we do not want, this approach proposes the reutilization, reuse, and recycle of the product. However, achieving this idea is not an easy task. We need difficult processes which will create important impacts.
Here, we are going to present different sectors in which circular processes can be applied, and also explain some of its expected effects. First, the use of less primary resources can be applied through the following: recycling, for example, in the automobile industry or textile industry; efficient use of resources, in the building sector or the food sector; utilization of renewable energy sources, for example in the chemical industry or the forest sector. The second circular process is to maintain the highest value of materials and products, and can be applied through the following: remanufacturing, refurbishment, and reuse of products and components, which is applied in the automobiles; product life extension, which can be applied in various sectors such as household appliances, textile industry, and more. The last circular process is to change utilization patterns, and can be achieved through the following: the use of a product as a service, in transport such as car sharing or the building sector; sharing models, transport or clothing sector; and third, by shifting consumption patterns in the food sector or publishing sector. Going back to the processes of recycling critical raw materials, there are some barriers to improve. Improving these barriers could bring significant benefits to the EU, such as reducing dependency on imports from third world countries. An example of product lifetime extension and remanufacturing is the building sector, as construction is considered to be one of the sectors with greatest cost-saving potential. This can be achieved by reducing waste and improving material resource efficiency, or by prolonging the life of an asset.
Main circular economy processes. It should be emphasized that the categories of circular processes are not mutually exclusive. Many of their elements are often interlinked, while in some cases, business can adopt a strategy that involves multiple circular processes. There are 8 processes that can be further classified into 3 different categories. 1. Using less primary resources. 2. Maintaining the highest value of materials and products. And 3. Changing utilization patterns. Recycling. Recycling has been defined by the United Nations as the reintroduction of residual materials into production processes, so that they may be reformulated into new products. For many decades, it's been the most traditional way of implementing circular economy principles. Reducing the extraction of primary resources through recycling can provide multiple environmental benefits and also help reduce GHG emissions associated with material resource use. Another process that can lead to the use of less primary resources is efficient use of resources. This process is linked to the concept of cleaner production and can involve both the careful use of resources and the replacement of resources that are hazardous or have a short lifespan. Cleaner production refers to improvements to both industrial production processes and products. Utilization of renewable energy sources. The increasing use of renewable energy sources is a core requirement for the transition to a circular economy. The combustion of fossil fuels for energy generation is by definition not restorative, yet oil, natural gas, and coal together still constitute almost 3/4 of total energy consumption in 2017. Remanufacturing. Remanufacturing can reduce costs for manufacturers as well as result in environmental benefits when fewer resources are being used. This was manifested in a UK study that estimates that in general, the carbon footprint of remanufactured products is at least 25% lower than that of new products, while in some cases this figure can reach 80%. Product life extension. Interlinked to the previously discussed economic processes, circularity can be implemented via practices of product life extension. As in the case of remanufacturing, product life extension requires an increased emphasis on the design phase of the product life cycle. This translates, for example, into standardization of components in terms of size or material. Sharing models. Sharing models seek to reduce underutilization of products and thereby support the more efficient use of resources. Sharing models can also contribute to the creation of genuine social capital and to a sense of community. It is generally agreed that these models have the potential to radically transform our consumption patterns to the benefit of the environment.
This section presents a set of examples of how economic processes are applied in different sectors and what the expected effects are. First of all, the use of less primary resources can be followed through recycling, which will have an effect on the automobile, textile, or chemical sectors. Efficient use of resources or utilization of renewable energy sources could be applied to the building sector, as well as the plastic, mining, and metals industry and the food sector. Secondly, maintaining the highest value of materials and products through remanufacturing, refurbishment, and reuse can be applied to the automobile industry as well as the manufacture of computer, electronic, and optical products, or the building sector. Also related to the circular process, we can find product life extension applied to these same industries. Finally, a change in utilization patterns shaped through products as services, sharing models, or shifts in consumption patterns could affect industries such as household appliances, transport, building, or e-commerce. At the EU level, Cambridge Econometrics and Biointelligence Service used a macroeconometric model to assess the impact of different resource productivity targets for the EU. The study estimates that improving the EU resource productivity by 2% could help create 2 million additional jobs in 2030. It also estimated that improvements of 2 to 2.5% in resource productivity could also have a small but positive net impact on EU GDP. In terms of focusing in recycling and reuse across the EU, the EEB built different scenarios around potential ambition levels in targets. This implied that around 635,000 to 750,000 additional jobs could be created by 2025 and near a million by 2030. Finally, using economic modeling as well as information collected through 150 interviews with experts, the Ellen MacArthur Foundation and McKinsey Center for Business and Environment estimated in 2015 that in the mobility, food systems, and built environment sectors, technological advancements combined with organizational innovations would allow Europe's resource productivity to grow by 3% by 2030, translating to total annual benefits of 1.8 trillion euros, which would lead to a GDP increase of 7%. As shown in several studies, we have indications that the circular economy has a strong potential to trigger significant economic benefits and create jobs as well as help protect our planet, and the externality that its misuse and destruction entails. So, what are we waiting for?